Welcome to the Online Gurukul. The Online Gurukul is a learning platform where we provide online tuition for 1st to 12th classes for CBSE, IB, ICSE and IGCSE boards for all subjects. In this video, you will learn about the rational numbers from Ms. Srisha.
Hello everyone, I am Sirisha from the Online Gurukul. I teach mathematics and science at the Online Gurukul. Today we are going to discuss the topic rational numbers. We have come across various sets of numbers in our previous classes, such as natural numbers, whole numbers, integers. Let us have a revision through it. After that, we'll go for rational numbers. The numbers that we count are called natural numbers. Natural numbers start from 1 and they are infinite in number. All the natural numbers along with 0 are called as whole numbers. Whole numbers start from 0 and they are infinite in number. All whole number along with the opposites of natural numbers are called as integers. Opposites means having opposite sign. So integers do not have a starting number or ending number. We cannot say even starting number or ending number for integers. They are also infinite in numbers. So let us learn what are rational numbers. So natural numbers set is denoted by n. Whole number set is denoted by w. Integers is denoted by I. Rational numbers is denoted by q. So rational numbers are the numbers. We can call a number rational number if it can be expressed in p by q form, where p and q are integers. Where p and q are integers. It means q cannot be 0. If q is 0, the value cannot be determined. So we have to be able to express it in p by q form. Q should not be 0 and p and q must be integers. So we can take an example, 2 integers minus 2 and 3. Minus 2 by 3 is a rational number. 5 by 6, 1000 by 1001. So all these are rational numbers. We can say 8 by 7. We can say 1800 by 7. All these are rational numbers because we are able to express these in p by q form. So you may have doubt. Shall we call fractions rational numbers? Yes, we can call fractions as rational numbers. But all rational numbers cannot be fractions. The only difference is if we are able to express a number in p by q form where p, q are integers are known as rational numbers. If we are expressing a number in p by q form where p, q are natural numbers, it is known as fractions. Every fraction is a rational number. Every rational number need not be a fraction because fraction means part of a whole number. So all numerator and denominator must be a whole number. Okay, where PQ must be natural numbers or it can be 0. Okay, PQ must be natural numbers. 2 by 3 is a fraction. 3 by 4 is a fraction. 5 by 6 is a fraction. 17 by 8 is a fraction. But if I say minus 17 by 8, it is only rational number but not fraction. And I can call all these rational numbers. So you may have doubt, are there any number which cannot be expressed in p by q form? Yes, definitely. So let us learn what are those. So what are the numbers which cannot be expressed in p by q form? I told that p by q form, it should be expressed in p by q form. So any p by q form can be written into decimal form. The decimals are of 3 types. Some decimal numbers end after certain number of digits. They are known as terminating decimals. Some decimals do not end. Some fixed number of digits used to repeat. Or we write it as 2.348 bar. The set of digits which are repeating, we keep a bar over it. That means the digits are repeating. So this is known as non-terminating repeating decimal or recurring decimal. Non-terminating repeating decimal. These two kinds of numbers can be expressed in p by q form. There is another set which cannot be expressed in P by Q form. Those decimals are non-terminating, non-repeating decimals such as 2.123571718. So without any order, some new digit will be coming. There is no pattern. There are no set of numbers that are repeating. Even it won't terminate. Such set of numbers are called as irrational numbers. So non-terminating, non-repeating decimals are called as non-terminating, non-repeating decimals are called as irrational numbers. About this, you will learn in detail in your higher classes. Are called as irrational numbers. These are the numbers which cannot be expressed in P by Q form. Generally, square root of a prime number, cube root of a prime number, or fourth root of a prime number. All these are non-terminating, non-repeating decimals, and pi is an irrational number. So these are all cannot be expressed in P by Q form, which we call them as irrational numbers. Again, let us come back to our topic, rational numbers. So we have studied properties of numbers in our previous classes. So those are closure property, commutative property, associative property, distributive property, existence of identity, and existence of inverse. These are the properties of the numbers generally we study in our lower classes about different sets of numbers. Let us study which operations are obeying these properties in rational numbers, which operations are not obeying. So it's quietly will be different from some other sets of numbers. So first of all, let us revise what is closure property. If we take two rational numbers, okay, and add them. Let us take LCM. LCM is 4. If we obtain a rational number by adding two rational number, if the answer is rational number, then we say that rational numbers are closure under addition. Rational numbers are closure under addition. All right. Let us check this closure property for subtraction. I am taking same kind of numbers, and I am checking for subtraction. Let us, LCM is 4, convert into same denominators, and it will become minus 1 by 4, right? So it's a rational number. So rational numbers are closure under subtraction. So when two rational numbers are subtracted, we obtain rational numbers only. Let us check for multiplication. If two rational numbers are multiplied, product of numerators by product of denominators. So this is a rational number. Therefore, rational numbers are closure under multiplication. Let us check for division. Division of rational number. Write the first rational number as it is. Division becomes multiplication. Fraction becomes reciprocal. Now the system is like multiplication. Product of numerators by product of denominators. 2 ones are 2 twos are. So it's 2 by 3. So by dividing two rational numbers, we obtain rational numbers. Those rational numbers are closure under division also. So rational numbers are closure under all the 4 operations. Are you clear with closure property? Let's go for commutative property. Commutative property. If A and B are two rational numbers, I added A and B. I got the value C. If I added in the reverse way also, if I get the same answer, I say that rational numbers are commutative under addition. Okay, let's check. 1 by 2 plus 3 by 4. We got 5 by 4 there now. I will add 3 by 4 plus 1 by 2. 3 by 4 plus 2 by 4. It's 5 by 4 only. So, rational numbers are commutative under addition. Rational numbers are commutative under addition. Let us check the same property under subtraction. Let us check for subtraction. If we take the case of subtraction, 3 by 4. So I am taking 1 by 2, 3 by 4 to rational numbers. I am doing 1 by 2 minus 3 by 4. I obtain minus 1 by 4, right? If I do 3 by 4 minus 1 by 2, it will be 2 by 4. I will obtain 1 by 4. Is minus 1 by 4 same as 1 by 4? No, no. So A minus B is not equal to B minus A. So rational numbers are not commutative under subtraction. Rational numbers are not commutative under subtraction. Let us check the same property under multiplication. I multiplied 1 by 2 by 3 by 4. Product of numerators by product of denominators. 3 by 8. Let us check the reverse. 3 by 4 times of 1 by 2. 3 times of 1 by 4 times of 2. 3 by 8. We got the same answer. So rational numbers are commutative under multiplication. Let us check with division. Write the first rational number as it is. Division becomes multiplication. See, division of rational number, very important. It may be a whole number, it may be a rational number, whatever it may be. Write the first fraction or number as it is. Division becomes multiplication. The other one becomes reciprocal. 2 ones are 2 twos are. 2 by 3. Let us check the reverse. We are getting the same answers or not. 3 by 4 divided by 1 by 2. So 3 by 4. Division becomes multiplication. Fraction becomes reciprocal. 2 ones are 2 twos are. I got the reciprocal answers. These two are not same. So rational numbers are not commutative under division. Rational numbers are not commutative under division. Next property is associative. So associative also similar to commutative. It is also regarding order of the numbers we are operating. Okay. So A plus, suppose we have to add 3 numbers. If we are adding in any order, if we are getting the same answers, we say that rational numbers are associative. See, if some numbers are commutative, it will definitely be associative. So they are good at, so addition obeys commutative. Addition of rational numbers obey commutative law. Therefore, it obeys associative law. You can try with any numbers. Because commutative and associative are related to order of the numbers we are adding only. So it is acceptable to commutative property. It is acceptable to associative also. Addition obeys associative law. As subtraction does not obey commutative law, it does not obey associative law. Subtraction does not obey associative law for rational number. As multiplication obeys commutative law, it obeys associative law also. Means we can multiply the numbers in any order to get the answer in a simpler way based on the question. So multiplying B and C, then multiplying the answer by A is similar to multiplying A and B, then multiplying the answer with C. So multiplication obeys associative law of rational numbers, obeys associative law. And division does not obey commutative law. So division does not obey associative law. Never he will get same answers because it does not obey associative. Means we should not change order if only division is there. Even if you try also, it is similar to commutative law. That is why I am not taking any examples. You can try with some examples. So division does not obey associative law. So I hope you are clear with associative law, and let us go for distributive. So three numbers are there. I have to multiply the addition of B and C with A. It can be done like this also. This multiplication of A can be distributed to both the terms. And this is called as distributive law of multiplication over addition. Distributive law of multiplication over subtraction. And this does not hold good for division. This holds good. Distributing a multiplied number to both the terms holds good only for multiplication. A into B minus A into C. Suppose we have three rational numbers. 1 by 2, 2, and 3 by 4. 1 by 2 times of 2 plus 3 by 4 is same as 1 by 2 times of 2 plus 1 by 2 times of 3 by 4. It is same. So 1 plus 3 by 8. It is 9 by 8. Sorry, 11 by 8. Alright. Means it can be distributed. 1 by 2 can be distributed to both the terms. It cannot be done here if division symbol is there. It is possible only for multiplication. Do remember. In the similar way, multiplication over subtraction, we can take the same numbers. Distribute 1 by 2 over both the terms and simplify. It's possible. We will do this as per our convenience in the problems. We can apply any of the ways. 1 minus 3 by 8. That is 5 by 8. So this is called as distributive law over subtraction. Clear, children? Let us learn about existence of identity and inverse for rational numbers. Let us discuss what is an identity. For any number, if we add something, we are getting the same number. This added one is called identity. Can you say what is that added number? That's right. That is 0. Okay. So 0 is called identity, additive identity. So is 0 a rational number? Does 0 exist in rational number set? Yes, 0 exists in rational number set because it is an integer. All integers are rational numbers. So 0 is a rational number. So identity exists. Additive identity exists for rational number. Let us check with natural numbers. So for any set of numbers, 0 is the additive identity. So 0 doesn't exist for natural numbers. So for natural numbers, identity does not exist. Again, in whole numbers, 0 is there. For whole numbers, additive identity exists. For integers, additive identity exists. For rational number, additive identity exists. Let us check for multiplicative identity. For any number, if we multiply by something, if we are getting the same number, this multiplied number is called as identity. What should we multiply? Exactly, that's 1. So 1 is the multiplicative identity. 1 is called multiplicative identity, and it exists for natural numbers, whole numbers, integers and rational numbers. Because 1 is a rational number now. Because 1 by 1 we can write it, we can express it in P by Q form, right? So we know all natural numbers are whole numbers, all whole numbers are integers, all integers are rational numbers. So 1 is a rational number. So multiplicative identity exists for rational numbers. So let us study about the inverse. For any number, what should be added to get identity? This added number is called additive inverse. What should be added to A to get 0? That's right, it's negative A. The opposite of number should be added to get additive identity, right? This is called as inverse. So plus 1 exists in rational number, minus 1 also exists in rational number. Plus 1 by 2 exists, minus 1 by 2 exists. Plus 1 by 100 exists, minus 1 by 100 exists. So minus 1 by 100 is the additive inverse of plus 1 by 100. Plus 1 by 2 is the additive inverse of minus 1 by 2. Minus 1 is the additive inverse of plus 1 and vice versa. So inverse exists for rational number. Inverse exists for rational number. Can you say for natural numbers inverse exists? Inverse does not exist. For whole numbers inverse exists? Does not exist. For integers inverse exists? Yes, inverse exists. Because opposite numbers are there, na? Additive inverse exists. Additive inverse exists for integers. For rational numbers, additive inverse exists. Yes, additive inverse exists for rational numbers also. So for integers and rational numbers, additive inverse exists. For natural numbers and whole numbers, additive inverse does not exist. Let us discuss multiplicative inverse. Multiplicative inverse. For any number, what should be multiplied to get multiplicative identity? This multiplied number is called as multiplicative inverse. So it's obviously the reciprocal. For A, we have to multiply by 1 by A to get 1. For 2 by 3, we have to multiply by 3 by 2 to get 1. For minus 2 by 3, we have to multiply by minus 3 by 2 without changing the symbol, reciprocal the fraction to get 1. So this is known as multiplicative inverse. So multiplicative inverse exists for rational numbers. So multiplicative inverse does not exist for natural number. Multiplicative inverse does not exist for whole number. Multiplicative inverse does not exist even for integers. Because the reciprocal of 2 is 1 by 2. 1 by 2 does not belong to integer now. So for integers also multiplicative inverse does not exist. But for rational numbers, we have multiplicative inverse. Very clear? So these are the properties of rational numbers, children. Two things I would like to discuss. One is multiplication of rational number. Another is division of rational number. Process to multiply to rational numbers. Product of numerators by product of denominators. Simplify if anything can be simplified. Multiply the numerators, what is left over. Write the answer. Multiply the denominator, what is left over, and write the answer. Okay. Division of rational numbers. Write the first rational number as it is. Division becomes multiplication. Fraction becomes reciprocal. So now division became multiplication. Same process. Product of numerators by product of denominators. Cancel if anything can be. Simplify if anything can be. Multiply the leftover numbers and write the answer. Am I very clear? So this is the topic rational numbers, children. These are the concepts. We will be having problems over this in the textbook. You can try and you can easily solve them with this concept. So thank you for watching. Have a good day.